Welcome to my shop today. Today we're going to learn how to build one of these wooden airplanes. This is a model with a 2-foot wingspan. In addition to being a model, it can also be a weather vane. You can put it on a metal peg like this with a little hole in the bottom of it, and that will allow the model to spin into the wind, and the propeller will spin in the wind. So I have a place to put my models out in front of our house when I want to do that, but I usually keep them inside because the weather's pretty hard on them, and I put a lot of work into them, and I don't want to enjoy them longer than about 2 to 3 years that they will last outside. The first thing you need to do to build one of these models is to find a picture, a side view, a front view, and a top view. You find one of these drawings, and then what I do is I print it on my printer at home. And on my printer at home, that drawing was approximately 10 inches. Then I knew that I wanted an airplane that had approximately a 2-foot wingspan. So then I knew I needed to blow it up from 10 to 224, which is a 2.4 or 240%. And I could go to the copy shop and have them expand it 240% and print it on that 30-inch wide paper that I was showing you. Once you have it printed on the paper, then you cut out your side view. This is the side view of the Piper Archer that I cut out. And then I cut out also a wing. This is, you only need one side because you can do the left and right wing. And then I cut out the elevator as well as a top view. Once I had these cut out on paper, then I took and I went over, and I have a piece of melamine that I used, and I laid the paper onto the melamine and traced out the shape that I wanted to cut out. Then I used my jigsaw to cut a rough shape, and then I used a sander to come up to the exact line so that I had an accurate and smooth pattern that I could use to actually cut out the actual parts. So I cut out a side pattern, cut out the pattern for the elevator, cut out a pattern for the rudder, cut out a pattern for the wings. Those are the 4 patterns that I needed. Once I have this cut out on these kind of patterns, then I can make multiple copies of this part pretty easily, and I can actually build multiple of these airplanes. I usually build 2 of these airplanes when I'm building them, one for me and one for whoever I'm building it for. So I'll build one for my son, and I'll build one for me. I've built 4 other of these models, different kinds of airplanes, a biplane, Spitfire, a Corsair, P-38. So different airplanes that I've made, but all using the same techniques that I'm going to show you today to build this Piper Archer. Once you have your patterns, then you can use your patterns to trace onto the material that you want to actually cut it out on. And I use 1/2-inch select wood. I found that I can find this at Lowe's. They have more selection than some of the other places that I've looked at. So for the wings and for the rudders, I use this 1/2-inch material. And then for the body, I use standard 3/4-inch pine. You can see in this 3/4-inch pine, this has a little bit of a knot in it. So you can't have any knots in any of the wood. So you need to find boards that are perfectly clear or sections that are perfectly clear. But you only need usually about 2 feet, and it's fairly easy to find boards that have 2 feet that don't have any knots in them. Here's an example. Here's one that's almost 30 inches, and it doesn't have any knots or anything in it. However, this one isn't very straight. I don't know if you'll be able to see that in the camera or not, but it's kind of bowed. So you really need to go through and pick out and be selective of the boards that you buy. You can buy select pine, but it's not necessary, and it's quite a bit more expensive to do that. Once you've got your wood, then for the rudder and for the wings, you can just use the 1/2-inch pine without doing anything to them. But you can see that on this airplane, the body is pretty wide, much wider than a single board. So you have to laminate together, boards together, and I had to laminate 4 of these 3/4-inch boards together. That is 3 inches wide. In order to keep the boards when you laminate the boards together, you want to make sure that you cut them extra long. You don't want to cut them right to the exact length you want. Give 2 or 3 inches on either side, and then drill a hole on the ends of the boards and put a dowel through the boards on both ends, and that will help keep the boards aligned while you're gluing them together. Put a lot of glue on there. Don't skimp on the glue. Make sure that it's very, very, that there's a lot of glue on there. And then use a lot of clamps, clamp it down. And I like to leave it overnight in order so that that can dry and that can have a good laminated piece of wood to work with. After it's finished laminating, I like to put it on, I have a table saw, and I like to put it on a table saw and just square up all the edges so they're exactly aligned. And then that can sometimes help you to do the rest of it. All right, when you're ready to start cutting, what you do is you take this double-sided tape. This is Gorilla tape. This is a Gorilla Bandit 2-sided tape. It's the 3M double-sided tape that has kind of foam in the middle. Isn't the greatest. This is a much better kind of tape if you can find it. What you do to use the Gorilla tape is cut a little piece of tape. Go ahead and put the tape on your pattern. And you just need a little bit of tape on either side of your pattern, like so. Then you peel off the backing on the double-sided tape. So I've peeled off the backing on the double-sided of the tape. And you stick that right there to the board that you want to cut. You don't want to cut on an angle. You want to cut along with the grain. So you put that on your board. I'm going to demonstrate this using this rudder right here. Put your pattern onto the board. Make sure you orient it depending on how the wood grain goes. I like to have the wood grain going straight like this. Go ahead and just trace it out. There you go. So we have it traced out on our board right here. Then the next step is to cut it out. And I like to use my jigsaw for this. So we're going to cut this out with the jigsaw first. And when you cut it out with the jigsaw, you don't want to be super close. You just want to cut out within a 1/4 inch or so. You just want to try and take the material off around so that then you can use your pattern bit to do the final cut and to get a good shape. I have this right here, and I'm going to cut it out with the jigsaw. There we go. Now we have a rough cut. And you can see that it's about a 1/4 inch outside each of those, and now it's ready to be cut with the router to the final shape. First, before I cut it with the router, I have to put double-sided tape on it. There's my double-sided tape. I'm going to peel off the blue backing. There you go. That's peeled off. Put this down there like so. Okay. Push down on it, make sure it's good and connected and good and taped down. Okay, so I have my pattern, and it is double-sided tape down to the 1/2 inch board that I want to cut. And I've put in my pattern bit into my router, and you can see that I have the router set just so the pattern bit exactly matches. Bearing will ride right on the router and cut out the shape that I want, and then the cutter will cut the board. So that's what we want. Sometimes it can be a little bit difficult to get the router to be, when you have a shape like this, to get it to be able to be clamped down. So you might have to try a couple different shapes. So once you get it clamped down, or you can reach in and you can run your router without hitting the clamp. Okay, good. You can see that you can get a very nice edge so that the pattern is all cut out. I'll go ahead and go around this whole shape now. When you're cutting out the body, you'll have a fairly large block of wood. You want to cut out the side view first. So you'll have a profile, side view, but this will all be flat and it'll be perfectly wide. It won't have any contour on the top. So you aren't able to cut the width with a bit like we've been doing with the other pattern bits. So you just have to lay the width on top of your model, mark it with the pencil, and then I either cut, like I often cut these angles with a saw, with my table saw, and then do the rest of the shaping with my sander, with the belt sander. Notice on this model, there's two kind of lines on the Archer. It has kind of a center part that sticks up with the nose that matches up with the propeller, and then it has two little side cowls. It has kind of a line in between them. In order to create these, I used a file to file down and create these two lines so that they were nice and straight. And then after I had them with the file and that they were straight, then I used a piece of sandpaper to round the edges off and to make it all a little bit more rounded rather than having just a flat edge like you might get with a file. Notice if you look at the airplane here, the wings are not perfectly level. They don't come out straight and level like so. They've got a little bit of an angle to them. It's called a dihedral. So on the Piper Archer, on the model, what I did to try and get this dihedral, did a little math. It is 1.5 inches of rise over the total wing length, which on my model is 12.25, so that the total wingspan is 24.5 inches. So you can do a little math. Tangent's the opposite over the adjacent, so 1.5 over 12.5, so the angle is equal to the arc tangent of 1.5 over 12.25, and that leads to an angle of 6.98 degrees. Obviously, you're not going to be able to, get that accurate, but about 7 degrees is what you're looking for on this cut right here. Rather than having a perfect perpendicular cut, you want an angle of about 7 degrees. So on my chop saw, I can loosen the back here, and instead of being perfectly perpendicular, I can move it up and use this gauge in the back. You can see that's 10 degrees, 20 degrees. And we're going to try and set this as close as we can to 7 degrees and then lock it in there. And what I did is I cut the angle first before I cut the length of the wing. So I cut the angle and then I measured out after I had the angle that I wanted, and it was when I put two pieces together, it was coming up 1.5 inches on the side. Then I cut the wing to length and went on from there. After I had the wings cut and I just glued them together, I just butt jointed them and glued them together. Then I cut out a piece like this shaded piece right here, a very narrow piece, but it has a lot of glue surface here, so it's a long scarf joint on either side of this butt joint, and that gives a lot of strength to where these wings are connected. It also flattens out the area that's going to go into the dado on the bottom of the dado as well. And then after you are able to join that, the bottom of the wings will be sticking out just a little bit, like you can see here in the drawing, about 1/8 of an inch in the middle. And you can just sand that down real quick with a sander to make it perfectly flush with the bottom of the airplane, so that it all molds together well. When I cut the wing, you can see where the joint is right here. I cut a 2 1/4 inch dado across the body of the model, a 1/2 inch deep. And then I cut a U shape out of the wings that I used the body to trace exactly where that needed to be cut, and I cut it with a jigsaw as tightly as I could, and then I sanded it so that it would fit perfectly against each body. And then I marked each body. So this is the A body with the A wing, and I marked, because I'm making two, I mark the other one as the number one body with the number one wing, so that they all matched together. And I did that because the wing actually doesn't follow the bottom of the body. It actually comes up above the body some, and I wanted to try and recreate that a little bit. So I didn't want it couldn't do that with a joint in that part of the wing. So I made it 2 1/4 inches wide, where the wing goes through the bottom of the body. Here you should be able to also see this is the balsa wood that I put. I dug out the body here, all the wood that I could, as much of the wood as I could. I used a drill, I used my Forstner bit, and I drilled out as much of the wood in here as I possibly could, leaving about a 1/4 inch lip on the side, so that I could put a piece of balsa wood in. I got this started actually, I made a little template. Here's the template. And I was hoping that I could use my router to just route inside this to have a really nice, even shape. But I was never able to actually get this to stay on and with the body and get it all clamped up and stay like I wanted it to. So in the end, I just traced this shape that had a 1/4 inch in from the edge of the body and then stopped right here. And then I used the router by hand to cut an 1/8 inch deep recess into the whole area, because the balsa wood is 1/8 of an inch, so the balsa wood would just sit right in there. Slightly less, so the balsa wood was sticking out just a little bit, so that when I sanded it I could make it perfectly even. Even though I dug all the back out here, you can see I put 1, 2, 3, 4 lead weights in the front, right up here in the nose, in order to try and get it to balance and lay flat, or sit flat when it sat on its wheels. On the aileron, I decided to cut out this part that's dark here. I decided to go ahead and make a little cutout, and that way when I slid this into the body, I wouldn't have a 1 1/4 inch dado in the body, and I felt like that was going to make it pretty weak. So instead, the cut into the body is only about an inch, really only about 1/2 inch into the body. So instead of having a cut that comes all the way in, it's only about half of that. And that also allows it to line up on the side of the body, and that helps keep the aileron straight, so that the body comes out perfectly perpendicular to the aileron. One of the things that I always do on my models is to cut out the control surfaces, like these elevators and the rudder, and that gives the model a lot of detail. And in order to cut those, what I use is I use this Dremel tool that has a gauge on it that I can run along a straight edge. So I can run this right along a straight edge and cut a straight line. I use a little straight cutting tool like this in the Dremel tool, and can cut right along a straight line. It's fairly easy to do, but because your wing will not be perfectly flat, it's sometimes hard to get the straight edge to be in a good place. So when I can't get it in a good place and I can't do it with the Dremel tool, then I use an X-Acto knife with a razor blade and do that kind of a cut with a V, and cut out a V of the wood, and then come back with a 120 degree sandpaper along all these parts, and clean it up and clean up the details. So I used a 1/4 inch brass rod like this one to do the landing gear. If you can see, there's a 1/4 inch rod that goes up through these little pieces of wood here. It actually has a 1/4 inch rod coming through it. You can see the end of the rod. And then I drilled a 1/8 inch hole into that rod to put an 1/8 inch brass rod in, and then I soldered them together. That makes a very solid connection for the landing gear, and obviously it's bent at a more or less 90-degree angle for the wheel to go through. The wheels, when they come from the factory, won't fit an 1/8 inch rod, so I actually had to drill these out. And if you do that, or when you do that, you want to use some WD-40 on the drill bit to be able to provide a little bit of lubrication when you're cutting through the wheels. In the front, I used a 1/4 inch rod, but then I also used some flat plate that's about 3/8 of an inch wide and about a 1/16 of an inch thick. And I bent that into a U shape. And then I used an 1/8 inch rod coming that I drilled into the 1/4 inch rod, and an 1/8 inch rod stuck out to about the middle here, that I could line that all up and solder it. And then after it was all soldered, then I came back with a Dremel tool and ground out the 1/8 inch rod so that it was flat, so that it wasn't sticking out too much. And obviously this 1/8 inch rod is not finished yet. It's just there as a placeholder so I can do some model fitting. Take the 40 grit paper off of here and put it with 80, so it's not quite so aggressive. You can see with the 40 grit you got some pretty severe scrapes. With the 80 it'll clear it up a little bit. That's quite a bit smoother. And once I get it to that point, then I'll use a hand sander with 120 grit to round this front part. Okay. So similar to the other sander, even though I'm using a finish sander, I've got very heavy grit. I've got 40 grit sandpaper on this so that I can shape the front of this rudder. There you go. So with 40 grit, I've really rounded the front of the rudder here and over the top of this ridge, and really got it to the shape I want. Now that I've got it with 40, then I would go ahead and do a pass with 120 to make it all nice. So I put 120 on. Clean it up, smooth it all out, get it all like I really want it to look, and get it nice and smooth. Now I have a rudder, and the rudder is round in the front and then back to the middle. So it's important that you make the shapes of the different pieces like an airplane really would be. So on wings, the top is rounded and the bottom is flat. On ailerons, the top is rounded and the bottom is flat. On rudders, it's rounded in the front and it comes back to the middle. So if you do those things, it'll help to make the model look more realistic. Here on this model, you can see it's rounded on the front. It's got more of a rounded top, and then the bottom is more or less flat. That's how you want to make the wings. Same way on the elevator. The top is rounded, The bottom is flat. No modifications to the bottom, just to the top. And then the rudder. The propellers for these airplanes are built by using a wood screw that doesn't have any threads at the top, and then a nylon washer goes on the top, and then the propeller itself, and we'll talk about how those are built. The propeller goes on that shaft, and it's able to just spin, and then another nylon washer at the back. And those nylon washers allow enough slop for the propeller to spin when it's actually on the airplane. And in this case, this model, I built the propeller so it would just be long enough so it would be ½ inch off the ground, so it wouldn't quite hit the ground. And that's, most of the airplanes, you build the propeller a little bit bigger than would be to scale. But this is as large as I could build these airplanes, and you want it as big as possible in order to take as much wind if you're using it as a weather vane, so that it will catch the wind and spin. But this is more of a model than a weather vane. So it's going to be on the ground, so it could only be, this is as long as it could possibly be. Okay. I'm going to talk a little bit about how to build these propellers. All the propellers are built with this same sort of a pattern, with a paddle. Start down narrow, come out wide, and then a lot of propellers have a circle at the end. These particular propellers on the Piper Archer are fairly square and they're fairly narrow. So I'm just traced out a shape that I kind of wanted. These are 1/8 inch plywood. You want plywood so that the wood won't warp. The plywood will stay straighter. And I cut out the blanks, or cut out the general shape, and shaped it with taped all the pieces together. So I taped this side and this side together, and then shaped it with the sander, and that way both the left and the right turn out to be identical shapes. They also then get each individual, I have to take them apart, and then each individual make them more narrow on the edges and on the ends than they are in the middle, and that will give them kind of a propeller looking shape. The propellers use this 3/16 dowel, or 5/16 dowel, just a little bit bigger than a 1/4 inch, so 5/16 dowel. And this is the dowel right here. It needs a slot cut in it that will slide over the propellers, so it will go together like so. I cut these slots on my table saw. The way that I do that is I drill a hole in a board like this. Then you can take the dowel, push the dowel into that slot, and then just run it through the table saw with exactly the right depth. You can adjust it until it's just exactly the right depth. And then once you have it all set up, you can cut quite a few of these fairly easily. So I would recommend that once you have it set up and the slot is right in the middle of the dowel, that you actually make several of these. I made 4 extra so that I can use these maybe on other models going forward. I don't have to set that all up again. Anyway, once you get that set up and you glue the propeller to the dowel, then you can work on the nose cone. In order to do the nose cone, I use a 3/4 inch piece of dowel, and I'll use this dowel jig that I have. It just uses a 3/4 inch Forstner bit, and I drilled a hole just about a 1/4 inch deep in this piece of wood. And then I can put this in my drill press, line up the drill press, line up this piece of wood with this hole, clamp down this board to my drill press so that it can't move, Then I can take the Forstner bit out and I can replace it with the 7 32 bit. That's the size for the hole in these props. And I can take the 7 32 bit, put it in my drill press, and then I can drill holes and it'll be right in the middle of that dowel. This is a little bit long piece of a dowel. What I do is I start out with a piece of dowel that's about 3 or 4 inches long, and I take it over to my sander and I rotate it around on my sander so that I make the cone shape of the propeller, the nose cone really, not the propeller. And that way I get a nice even round shape. And it would be longer, the dowel would still be sticking out. I wouldn't have cut it to length. Once I am happy with the nose cone part of it, then I would drill a hole all the way through from left to right. That would fit these 5/16 inch dowels so that the dowels can go in, and I would just drill all the way through so that they're perfectly straight, one exactly opposite the other. When I get that done, then I can come over here and I can put the dowel in this holder, and I can use my drill press with the 7 32 inch drill to drill down through. Now obviously I would cut it short here so that I could drill all the way through it at that point. And then I would have a filled nose cone. Then you can, in order to put the propeller on, you can see how this just slides into that slot. And then this part of the dowel goes into the hole on your nose cone. In order to align them, you can use this jig. This is a 45-degree angle, and you just put your put it like this so you can see. Put your nose cone facing the 45-degree angle, flat, and then you can align your propeller with this 45-degree angle. And that way, so I got that one perfect, and I turn over and do the next one. And that way, both of these angles on the prop are exactly the same angle. And I don't have to do anything. It makes it really simple to make the angles line up good and make them look good. And that 45-degree is good. You just need to make sure that your nose is pointing in the same direction as you rotate this around so that the propeller will be proper and it will get into the wind and work properly. So I used 1/8 inch, or this is 3 32, a little bit smaller. I couldn't find the 1/8 inch. This would be fine as well. I drill a hole right here and about right here so that there's two holes in this rudder. Put this into it so that they're sticking out, and use this metal as a dowel. I like to use the metal rather than using wood because it's stronger and it is also a little bit more flexible. You can bend it a little bit and work with a little bit. So I'd recommend using brass rod. This is 3 32. This is probably ideal for doing dowels in the rudder. To do the dowels on the rudder, I just use the right size drill bit. You just want to be careful not to drill obviously through the whole board. So you have to only put it where there's we're just trying to use this as a lineup pin and to keep it together. Once you've got those drilled, then we're going to push the metal piece into the hole. Then we'll take a pair of side cutters and cut this off so it's about 1/2 inch long or so. I'm going to use this for this other one here. And now I have 2 pieces that will help to align my rudder on the airplane. I would line this up on the model where I actually want it to go. I would mark these holes using once I've put them into my rudder, and then I would drill them out with the drill. And then hopefully when you put the rudder into those holes, it will align perfectly. And you can see that I've lined this up right up here, right with the center where those boards come together. So I have a nice center line mark right in the wood, and I can keep my rudder nice and straight. I forgot to mention, when I use epoxy to glue these metal, when I'm putting metal into wood, I use epoxy rather than using the wood glue. And I also take some sandpaper and scrape up the metal so that it has some surface for the glue to bond to. I actually might cut that just a little bit with a hacksaw so that it's got some places for the glue to get a good bite when I put it in to the wood. So once it is solid, then it won't be able to come out. In order to make this airplane a weather vane, it's necessary to find the center of gravity so we can mount a mount right at the center of gravity. So what I've done is just taken a dowel and laid it on a board here that I can lay across, and then I can move it forward and backward until I find the spot where the airplane is just being balanced. And then I'm going to mark the front and the back of that dowel like so. And I wasn't very careful, but this is where I marked it carefully. The front of the dowel, the back of the dowel, the CG would be right in the middle of that. And then I can also put that on my finger and just verify that that is the center of gravity, so that I can mount, make my mount right here in between those two marks, right in the middle of them. So in order to make the mount, you need a 3/8 inch brass pipe. So that's just 3/8 of an inch pipe, and you need a 1/4 inch brass rod. And the rod will go up through the brass pipe. It'll be 1.5 inches long from the top to the bottom, and we'll sand the top of the brass rod so it's nice and even and polished, and it'll be really slick. And then at the top of that brass rod, in that will be a piece of bolt. We take a 3/8, take this bolt that's 3/8 of an inch around, and cut off a little section of it. This is approximately 3/8 of an inch long. I just cut it off, this bolt, and then we will polish the end that's going to hit the brass support, and that will make our pivot point, and it'll make it with not very much friction. And this brass will go over like so. This will be in the top of the hole. So you want the hole to be 1.5 inches plus the thickness of your bolt, which for me is about 3/8 of an inch. So I need 1.5 and another 3/8, 5, 6, 7, 8. So 7/8. So I have used my drill press here. I've leveled out the airplane using this level, both forward and back and side to side, and I've put boards underneath the wing and underneath the body and by the tail so that it's all even, so that it won't move when I actually drill. And then I'll need to drill 1.5 plus 3/8, so 4 and 3 is 7, 1 and 7/8 deep, more or less, in this hole. So now I've drilled a hole into the bottom of this that will be where the shaft will go right up into that hole, and that will allow the airplane to just spin. And I can check and see that the CG is pretty good at this point. I can tell. Now all I have to do is to cut a little bit of brass rod that will go up in there. But first, at the top of that hole will go that bolt, top of the brass rod. That will allow it to have a nice, good surface to be able to be low friction and move. Going to mix up some epoxy to go on this bolt. Put some on the top. Make sure you've got that in the right direction so that the part that you polished is pointing down. Take a piece of aluminum and tap that down. Make sure it's good and seated. Once I get the right distance, then I can put the brass tube in the 3/8 hole I cut in this 2x4, and then I can use the saw to cut this off. I haven't measured yet, so I'm not going to cut it, but that's how I will do it. With the sandpaper, going to rough up the edge of this brass tube so that it's not super smooth. That way the brass tube has a bunch of edges in it and it'll stick to the glue better. There's the brass, 3/8 brass in there. I'm going to use a board. Use something like that so I don't ding the edge of the brass and ding it all up. I use my shopmate, some aluminum poles to mount my airplanes, and that goes right into the mount that you would use to use them as a weather vane. Makes a great way to paint. Moment of truth. Primer first. So this is the first coat of the primer, and it's a filler primer, so we're trying to fill in all these holes and stuff. It's been a little bit light. I'm not sure if this is going to work, but I've sanded it to 220. I'm going to wipe it off, and then we'll take a second coat and we'll see how we look and see if we need to do a different primer or not. Second coat, see how this goes. Two coats, pretty much. This one's got a little bit left in it, but pretty much 2 spray cans and 2 coats. Tried to put it on pretty thick. We'll see how that works. Been using this Bondo glazing and spot putty. You can see some of the red marks here. Hope I haven't sanded yet, but I hope this will work out well. I've got a little spot here that I need to fix. It's pretty easy to do. Just squeeze out a little bit of this spot putty on the area you want, and use one of these spreaders. This is a spreader for it's plastic and it's not going to scrape the model, so I think that'll do it. It's supposed to dry in like 20 minutes, so it shouldn't take too long. Just wipe it off, and I'll sand it all down, and it should make a good finish. Then I'll finish all the little pinholes and stuff in the model. Here's another little one I see. Just fill in a little pinhole there. These are the paints that I used, including the primer. I used painter's tape to create masks that I could use for the paint job. Here's the mask for the green area on the airplane. I did use also some plastic wrap sometimes, and that keeps the paint, the tape from being right on the model, the dark green paint. I used pictures that were scaled to the right size in order to create the shapes and trace those out onto the painter's tape and then cut it out with an X-Acto knife. Here are the pin stripes that go on the sides of the airplane. You can see they're quite narrow. They're kind of tricky to get on there the way that they needed to be. But now I'm painting the pinstripes with the orange, and then here is the final result, and I think it turned out really well. I really like the way the pinstripes turned out. To do all the text on the airplane, rather than trying to paint it, I create decals. And what you need to do is to go and take images of the different decals. There's the UND, there's this number of the N number on the airplane. Take close-ups of the various texts that are around the airplane. So there's the Archer, there's the little Piper logo, then edit them. This is an edited photo. I edit with Photoshop, and I've deleted the rivets and things, and then I delete the background, this white background, so you'll only have the text and the graphics. I use the TIFF format, TIFF. I've been using the 16-bit TIFF so that you get accurate colors, and I use Photoshop to print them. Here's a picture of the avgas. The other side, left and rights are different, so you need images of left and right. And then here's a simple, the emergency locator transmitter is located behind that panel that I'm going to put on my plane. So just take images of all the different graphics on the airplane. I edit them in Photoshop. I've adjusted the colors when I needed to get like on these graphics right here. I adjusted the colors on those letters to match the actual paint on my model rather than what is on the airplane, and that way the decals and the actual paint job on the airplane match. These are the materials that you need to do the decals. You have some pledge floor finish. You put that on the model where you're going to put the decal, and that makes a nice even flat finish where the decal can adhere to. Before you apply the decal, you spray it with this decal bonder spray. Spray that over the decals on your sheets, and they recommend that you let it sit for 24 hours. The person also recommended that you put 3 coats of the bonder, and then and let it dry for 24 hours. After you do that, then you cut it out. You put this in some water. Let the water will cause the decal to come off the backing paper, and then you can put a little bit of water on your model, and you put your decal on there, adjust it to where it needs to be. When you're happy with where it is, apply some of this micro set on top of it, just a few drops, and that causes it to basically fuse with the model, basically go onto the model and make it look like it's part of the model rather than just being attached on the surface. I'm going to spray the decals with the decal bonder spray that protects the ink, keeps it from running. Need to tape the decals down, because if you don't, then they can be blown away when you start to spray. The decal bonder that I use, the testers, interacted with my inkjet printer this time. It didn't do that before, but you can see where the red bled after I sprayed the bonder on it. I thought that it might have caused that bleeding because it was old, so I went to get some more decal bonder. Well, it turns out Testers doesn't sell that anymore. And a little bit of research, they recommend that you use this Rust-Oleum 2x gloss clear. There's several other ones as well, the crystal clear, but this is the one they recommended, and so did the Rust-Oleum one, and that seemed to work just fine. It didn't cause any issues with the decals. So from now on, looks like that's what I'll be using. I'm gonna mount the tires on here so that I can put the decals on. So that I know how it's sitting, so I know when the airplane is sitting level. Cut out very carefully. Put it in the water. Yeah, the other one wanted to curl up, so I had to put it upside down for a second. Take my Q-tip and get some water on it. Get this all wet. Pretty liberal with the water here because I want to be able to move that decal. Now the decal's flat and it's ready to come off. Pull the paper out. And get it about where I want it. And I can pull the paper backing out from underneath the decal. It's pretty wet, so I can move it. It's like that. I think I'm pretty happy with that location. And dry it off just a little bit. Dry it off with and I'm rolling this. Trying to push out any little air pockets or anything in the decal. I'm going to put a little micro set on there. I'm just brushing some micro set on the top. The microset says to leave it for a couple of minutes. I've only been leaving it about 30 seconds. I don't want it to get too thin on this, and 30 seconds seems to be just fine. So I'm using my watch to do 30 seconds, and then I'm going to sponge it off with a dry clean Q-tip here. Okay, that's about 30 seconds. Okay. That looks good. When you want to print a white label, white lettering, you have to use white paper. You can't use the transparent paper because inkjet printers don't actually print white. They just don't print anything, and they expect the paper to be white. So you have to use the white decal paper and then print the background color around the outside of it to outline the text. And it's green so that it'll match up with this rudder so that you'll get the UND on that rudder flash, for example. Using a razor knife to cut out the inside of these letters so that as little of the green background is used as possible. That way the green mismatches, the background color mismatches a little bit. It'll only be just a little bit of it, so there won't be a large patch of it to look at. You can see just a little bit of green around the outside of the letters I've cut out around it. Put the decal down on one end and then pull the paper out. And I have a little model so I can see how this goes. There we go. That looks like it's in the right place. Once you get the decal where you want it, then I do use a little bit of this micro set. A little brush. Brush over it, brush over the edges. And give it a minute and then dry it off. My Pledge floor care finish, I've had this for a couple years and it looks like it's getting just a little bit yellowish. I thought I would maybe go get a new bottle, but I couldn't find it in the stores. I did find it on the Pledge store, but they wanted $89 for it, so I'm not sure that that's what I would use in the future, but I've already got some, so that's what I'm going to use. There are some other brands that don't look like it's acrylic, but if they are a floor finish that maybe could be used. Not sure exactly why this acrylic one's not available readily, but I'm going to go ahead and use this even though it looks like it's a little bit yellowed. You can just put some of this onto this foam brush, pour it onto the foam brush and then brush it on. The first time I did it, I poured it on the model and then spread it out, and that gets too much of it on the model and it runs and makes spots and things. So it's better to put it on the brush liberally and then spread it with the brush, get it all over the top. In an hour it will dry, then you can flip the model over and do the bottom, and then you have to wait 8 hours to put a second coat on. When I put 2 coats over the whole model, and that will cover the decal and help it so that the edges don't peel up and that they're all stay finished. It also gives it a nice gloss over the whole model, over all the different painted surfaces. And that's it. I think that's the end. You can show you some of the final pictures that I took. Just you can see some close-up of the model, see the side and the decals and what the model looks like. Hope you enjoyed this video, and hope it, if you build one of these, that it helps you to build it. I primarily did this for myself so that the next time I build a model I can remember all the little tips and tricks that I learned along the way and I've forgotten. So this video is really to remind me of how this process all works.